All right, welcome back to calculus. So we are talking about test three uh, review for this. We're just going through the practice problems. So number five says we have a baseball team plays in a stadium that holds 55,000 spectators with ticket prices at $10. The average attendance has been 27,000, and when ticket prices are lowered, the average attendance rose to 33,000 rather. And you got this out of your textbook. So this is a homework problem, but I guess I didn't copy and paste the last sentence. Figure out what the ticket price has to be for the maximum revenue here. Should be the way this would read. Okay. So what we know, what we're going to have here. Okay. There we go. So we're given that we're going to say the revenue is equal to the ticket price times the number of attendants. Okay. And the thing about that is when it dropped to $2, when it dropped to $8, we had something happen. And then how many more people did we get? So when the ticket price said $8, what was the number of attendees? And he said that was, let's see, then it went up to 33,000. Okay, so we are, how much more do we have? So we have 33 minus 27. It looks like we get an extra 6,000 people showing up. So we got 20, sorry, we got, we got 27. Okay, so that's a number we might want to keep in mind, just for the sake of having it around. Okay, so I want to say something like we had $10, we subtracted, so I'm going to say we subtracted a certain amount by the tickets, so I'm going to say -2 here, and I'll leave myself a little bit of room because I'm not quite done yet. And then in order to get the amount that we have, we got 27 plus like a certain amount. So we got some extras here. Star one. Okay, so we got when it's lowered, it rose to 33. Okay, so we got 33 plus 6. Okay, so I'm going to say, well, 2 and 6 are both divisible by 2. So I was going to do it this way and say this is 10 minus 2x. And that would give us an attendance of 27 plus 6 divided by 2 is 3x. And to work that problem. Okay, I suppose you could put an x here, put an x here, and that would be the same idea there. Okay, so we're going to have that. I just usually like to keep the numbers smaller if I can. So that's my revenue, and we want to maximize the revenue. So we're going to have to go ahead and either do product rule, or we could multiply this out. Why don't we multiply this out? This is going to be 270, and then we have to multiply this thing out. So 3 times 10, or 2 times 27 is going to be minus 54x. We have a plus 30x. 2 times 3 is negative 6x squared. Let's clean this up a little bit. So we have r equals, and I have 270, and then 30 minus 54 is just going to be minus, I think, 24x here, minus 6x squared. We're going to set this equal to 0, and then see where it lands us. So we have, take the derivative, dr by dx, okay, and then we have negative 24 minus 12, 6 times 2, x equals 0, and we're going to solve for x. So we have negative 12x equals 24. Divide both sides by negative 12, we get x equals negative 2. Okay, so for this problem, raising the price instead of lowering it, raising the price by $2 is going to give us our optimal revenue here. So conclude here, raise the price by $2. Okay, and what's going to happen is we have 10 minus 2 times negative 2, okay, And what's going to happen is we'll have 27 plus 3 times negative 2. And then we have to do this arithmetic to figure out what the maximum is. 10 minus a negative 2, that's going to be 10 plus, well, 10 plus 4 here. And then we have 27 minus 6. So we have 14 times 21. When I went ahead and did that, I found out this was going to be 294,000. Okay, which is a bit bigger than what we started with, 27. Okay, it gives us what the, and that's really all we really need for the problem. They gave us some other information. It said, by the way, it holds 55,000, and we might want to check the endpoints just to double check some things, but we could do that. So things that I might want to check is, what if I did 10 minus 2x, yeah? And then we had 27 plus 3x. 27 plus 3x. So things I might want to check is, well, I would want to make sure, like, what if I set x equal to 5? Well, that would be kind of silly because that would be, we would end up with a zero price. So I might want to put it like, well, my domain for this thing had better be between 5 and something. I don't know if 5 is on the big end or the small end, but one of the endpoints for my domain here would be 5. Okay. Actually, that's not really true because we said that's just how much you would raise the price by. We could, or lower the price by. We could raise the price. So again, there's nothing wrong with it being negative. But one of the things you might want to check is like, okay, well, 27 plus 3x. What was the maximum capacity of this stadium here? It said the maximum capacity is 55,000. Okay, so might be 55K here. So if I go ahead and subtract 27 from both sides, back 27 from both sides, we have 3x equals, and when I did this, okay, 55 minus 27, no, I don't want that, I want this. We want 55 minus 27, we got 28. We have x equals, and we'll go ahead and 28 divided by 3. Okay. 8 divided by 3 here. So 9.33. So what would x have to be for me to do that? It looks like we'd have to reduce the prices by, we'd be giving away money. So what is the ticket price when the maximum capacity is going to be? 10 minus 2 times 9.33. So we can go through and do that. These things were not asked, but 10 minus 2 times 9.33. Right, so that would be negative 18.6. Okay, so we would have to give away, right? We'd have to give away $18 for people to show up to fill this thing out. This is kind of weird, but that's what this is looking like. So that's how you did this maximization problem. Okay, this is pretty standard kind of a problem, but that's pretty much how you go through and put this together. Okay, thank you very much. You have a great day. Study hard for the test, and I will see you guys when you take on the video when you take it. All right, goodbye.